where in particular we'll be focusing on the topic on angles of elevation and depression as well as bearings. Okay, in this webinar, we are going to recap on a few things. The first one is your Pythagoras theorem that you have learned before in your lower secondary math. Your trigo ratios of acute angles to calculate unknown sides and angles in right angle triangle. Your trigo ratios of angles and the relationship with trigo ratios of acute angles. And we'll briefly look at the rule as well as the cosine rule. And after that, we'll master the ability to apply trivial concepts to solve simple practical problems in 2 dimensions, including those that involve angles of elevation and depression and bearings. And after that, we'll have our question and answer session if there are any questions from the students. So let's do a brief recap of the very basic trigo. Okay, the first thing that we need to remember is Pythagoras theorem. And what is so useful about Pythagoras theorem is that it's used to calculate the length of any of the sides of a right-angled triangle. Please bear in mind that it must be a right-angled triangle before we are able to make use of Pythagoras theorem. So what this theorem says is that the square on the hypotenuse is equal to the sum of the squares on the other two sides. So the square of the hypotenuse, in this case is actually c squared, will be equals to a squared plus b squared. And just a quick recap on where the hypotenuse of a right angle triangle is that it is the side that is always opposite to the 90-degree angle in the right angle triangle. So the formula is actually c squared equals to a squared plus b squared. Now let us move on to the trigo ratios of acute angles. If we talk about trigo ratios of acute angles, the easiest way to remember is our Torcaso. What does Torcaso mean is actually short form for the ratio. For example, if we are talking about TOA means is tangent of the angle equals to your opposite, which is O, divided by your adjacent. So there's actually tangent theta. Then if we have CAR is actually the ratio of the angles for cos theta as equals to the adjacent side divided by the hypotenuse. Then we have SO is actually the sine of the theta equals to the opposite of the hypotenuse. So these are quite standard ratio of formulas that you must remember for acute angles. And please also bear in mind that trigo ratios for acute angles only applies to right-angled triangle and nothing else. After talking about trigo ratios of acute angles, we also talk about trigo ratios of obtuse angles. Okay, as this is a quick recap of what the formulas are, the trigo ratios of obtuse angles will be sine theta equals to sine 180 minus theta. In other words, the sine of the angle that is acute is also the same as the sine of the obtuse angle. Then for cos theta, it's actually slightly different from the sine because the cos of an acute angle is actually equals to the negative cos of the obtuse angle. So sine rule, again a quick recap about sine rule, it applies to any kinds of triangle that is not a right angle. And what you need is, as long as you have any two angles on one side, you are able to make use of sine rule to find the other side. And if you are given two sides and one angle that's opposite to one of these sides, you are also able to use the sine rule. So sine rule is just, again, it's a ratio of the sides divided by the sine angle as shown on the diagram. Okay, so we have A over sine A equals to B over sine B equals to C over sine C. That is the sine rule. Then we also have the cosine rule, which also works for a triangle that is not right-angled. And the cosine rule is used when you have all three sides. And once you have all three sides, you can find one of the angles, or you have any of the two sides. In this case, we have B and we have A, for example, and given an included angle. What included angle means? The angle that is sandwiched right between A and B. That's the included angle. And with that, we should be able to find the unknown, which is C. So as long as you have any three sides or you have two sides with the included angle, you are able to use the cosine rule. And of course, we'll make use of these rules later on as we look at some more examples. Okay, some quick tips before we move on to talk about angles of elevation and depression and bearings in greater detail is that, first of all, always check that your calculator is set to the degree mode. The reason is we have topics in E-Math, or some of you will be taking A-Math. We have some topics that make use of radian mode to do some calculations for circular measure and sectors of circles and so on. So there's a tendency for students to set the calculator to radian mode and have forgotten to switch it back to degree mode when they're doing topics on trigonometry. So when you're doing that, please always check that your calculator is set to degree mode before you proceed on with the question. The next rule that you need to take note of, if your question does not specify your degree of accuracy, your answers, if they are non-exact, it has to be corrected to 3 significant figures. And any answers that you have for workings is always corrected to 4 significant figures. And any non-exact answers for angles is always corrected to 1 decimal place if the question does not specify what is the degree of accuracy. And if you have right-angled triangles, you always use your Picasso to solve for it, or even your Pythagoras theorem. And if you do not have any right-angled triangles, you always use sine rule or cosine rule. So with these quick tips and our previous recap, let's focus on angles of elevation and depression in this particular webinar. So what exactly is angle of elevation and what exactly is angle of depression? Definition for angle of elevation is the angle that is sandwiched between your horizontal line and the line of sight to an object that is above the horizontal line. So a good example is you have this person that's standing right here. There's a horizontal line drawn, which is an imaginary line, from his line of sight. And then he's looking at the cloud up there. So the angle that it makes between the horizontal line and the line of sight is called the angle of elevation. So over here. Then if the person is looking down on the animal, over here, the angle that is between this horizontal line and the line of sight is called the angle of depression when the person is looking at the object that is below the horizontal line. So that is the difference between angle of elevation and angle of depression. So let's take a look at a work example. A simple work example in this case shows a lighthouse labeled as XY. It has a height of 60 meters. The angles of elevation of the top of the lighthouse Y from ship M and ship N are 58 degrees and 27 degrees respectively. You need to find the distance between the ships M and N. Okay, in this case, the drawing is provided for you. But sometimes in the examination, drawings like this are not provided for you. So you got to be able to sketch your own drawing and put in the information properly. Alright, so based on the diagram, what we do next is to label the appropriate information that we had in the question into the diagram. So we have a lighthouse that is 60 meters tall, which is denoted XY, and then it says that the angle of elevation to the top of the lighthouse to M is 58, degrees, and then to N is 27 degrees. You're supposed to find the distance between the two ships. So using our trigger ratios that we had seen earlier on, our trigger ratio in this case is to make use of tangent, which is 12. Okay, tangent 12 means we have to take the ratio of opposite over the adjacent. So in this case, the opposite side is actually 60 meters divided by adjacent, in this case is actually distance mx. So I can easily find what is the distance of mx, which in this case is actually 37.492 meters. Then using the same idea about finding the ratio of tangent 27 degrees, which is also your opposite, which is the height of the lighthouse, divide by the distance nx, we have the relationship of tangent 27 degrees, and that will actually enable us to work out what is nx, and in this case is 117.757 meters. So that means if we are going to find the distance between the two ships nm, we just need to find the difference between the distances. So if we find the difference in the distance, we actually have 117.757 minus away mx, which is 37.492. We end up with 80.264 meters. But as the question did not specify the degree of accuracy, we round it off to 3 single figures as what is required in the examination. So in this case, it's 80.3 meters. Okay, so this is actually a very small example regarding angle of elevation as well as trigger ratios for acute angles. Let's take a look at the next question. This question is slightly different from the first question because you have much more information and the diagram is not given to you this time. So the question is, Ali stands at a height of 1 meters. He looks out the window of his flat and he sees a taxi that's parked at the car park below, and the angle of depression is 30 degrees. So it means that he's actually looking down at the taxi from a height. That is why we have an angle of depression of 30 degrees. At the same time, Amar, standing 10 meters above Ali, sees the same taxi from the window, and his angle of depression now is 63. Okay, so Ali has an angle of depression of 30 degrees, Amar has an angle of depression of 63 degrees. Two things to calculate. The first one is to calculate the distance of the taxi from the foot of the flat, and you need to find the value of y, which is the height at where Ali is standing. So let's draw a simple schematic diagram. In this case, there's no need for you to draw the details of that, just a line to represent it, and a point to represent the location of the taxi. And then for clarity, what I do is I name the points. So in this case, point A is the place where Amar is standing. Point B is where Ali is standing. Point C is where the foot of the flat is. And point D is where the taxi is. So a few things in this question is that part A is to find the distance between the taxi and the foot of the flat, which in this case I call it as x meters, which is needed in part A. Then part B, you are supposed to find the height that Ali is standing. So I call it as y meters, and this is the task for part B. So what I do is I let the distance of the taxi from the foot of the flat to be x meters. And then I'm able to find out what is the angle BDC. So if you look at BDC carefully, BDC is this angle right here. So this angle is actually equals to 30 degrees. Why? Because based on the concept about alternate angles, this angle is actually 30 degrees, which is the same as the angle of depression of Ali. With the same note, angle ADC over here is 63. So ADC is this bigger angle over here. Angle ADC is 63 degrees. And again, it's based on the concept of alternate angles because the angle of depression of Amar is 63 degrees. So what we need to do is to formulate some equations to assist us in solving it. So the first possible equation that we may have is to make use of triangle BDC. If you look at triangle BDC right here, which is the smaller triangle that connects Ali to the line of sight of the taxi and the foot of the flat, we can easily make use of our trigonometric ratio for acute angle to find out what is the value or what is the relationship between the height y and the distance x. So the relationship in this case is tangent of 30 degrees is equals to opposite over adjacent, which is y over x. And that will give an equation of y in x that says y equals to x times tangent 30 degrees. So I just call this as equation number 1. Okay, so since I know that I have two unknowns x and y, I cannot just use one equation to solve for two unknowns. I need another equation to do the job. So the next equation that I can make use of is to make use of triangle ABC. If you have triangle ABC, which joins the position of where Amar is standing to the taxi to the base of the flat, I can see that tangent 63 is equals to opposite, which is y plus 10 meters, the whole thing divided by x meters. And then what I have is I have another equation that relates x and y together. So the equation is y plus 10 is equals to x times tangent of 63. That will give me equation number 2. Alright, so what happens now is I need to substitute my equation number 1 into equation number 2. When I do that, I end up with just an equation that involves my unknown x value. Okay, if you look at this equation that is being substituted, it's not difficult to solve for it because there are numerical answers that can easily be calculated using the calculator. So if you do it properly and you actually factorize the value of x out in this case, you'll find out that it's actually 1.853x equals to 10. And if you do a calculation using a calculator, you get the value of x equals to 7.2186. Round off 363 is 7.22 meters. So we've found the answer for part A easily, which is the distance between the taxi and the foot of the flat C. Then our next task is to find what is the height that Ali is standing from the ground, which is not difficult because we already know what's the relationship between x and y. We can easily just make use of our previous equation, which is equation number 1. Okay, and we substitute our x value in. Okay, so the equation number 1 is y equals to x times tangent 30 degrees. And you'll notice that I did not use the rounded off value of x because that will actually affect your accuracy. So therefore, I'm using the working answer that is more than 4 significant figures. It can be 4 or more. So in this case, I'm using 7.21886 to substitute into this equation. And when I work it out, I get 4.1678, and then I actually round off to 363 for the final answer. So the height that Ali is standing from the base of the flat is actually 4.17 meters. Okay, so we have seen two workings or two examples on angle of elevation and angle of depression, where we have to apply basic trigonometric ideas or rules to help us solve the question. Next part that we are going to talk about is bearings. What exactly are bearings? A bearing is an angle that tells the direction of one place that's relative from another. And how do we actually present the understanding about bearings is that first and foremost, your bearings are always measured in the clockwise direction. And number two, it is always measured from the north. Number three, it must always be written as a 3-digit number. So these are the three things that you must take note of when you're presenting your answer for bearings. So as a quick example, if we have a bearing of L from O, in this case the angle is 241 degrees. It is calculated from, number one, in a clockwise manner, starting from the north. It rotates all the way to the position L, and that angle is 241 degrees. So we actually read this as the bearing of L from O is 241 degrees. Okay, it seems very straightforward, but let's take a look at some examples to further understand about bearings. So let's take a look at work example 3. There are 6 things that you need to find from this work example. The first one is A from O. Alright, B is B from O, C is point C from O, D is this time the other way around. We have O from A, E is O from B, and F is O from C. Some of you may be wondering what's the difference between from A to C and from D to F. We shall take a look at the solutions to find what is the difference between them. So let's take a look at the question from part A to part C. Part A says, I want the bearing of A from O. So what you do is, with the crosshair of the compass situated at O, you know that you have to start from the north. So in this case, I start from north, and then I got to go clockwise to reach A. So when I do that, the answer is actually this angle over here, which is labeled as A. In this case, I can easily get the value of the bearing of A from O by simply taking 90 degrees minus away 30, because we are already given what is 30 degrees over here. So therefore the angle is actually 60 degrees. But because we are actually finding the bearing of A from O, we have to write as a 3-digit number. So for this kind of situation, you just need to add a 0 in front of it to be written as 060 degrees. That is for part A. Let's take a look at part B. Part B requires us to find the bearing of B from O. Like what I said earlier on, our crosshair for this compass is actually situated at O. So what you need to do is to start from the north, go clockwise, and find what is the angle that it makes when it reaches B. So in this case, it goes all the way to this position right here, and then what we do is we simply can get 180 degrees minus 20 degrees to give 160 degrees. And what kind of concept are we using here is the angles of the straight line will always add up to 180 degrees. So that is for part B. If you look at part C, we talk about bearing of C from O. So bearing of C from O means I start from the North Pole. Okay, I rotate, I follow clockwise, and then until I reach C. So in this case, it will just simply be 270 degrees plus an additional of 45 degrees to give me the answer. How do I get 270 degrees? Because I have from north, if I move to this point over here, this is 90 degrees. I move through another quadrant that is 180, and I move through another quadrant, I'll get 270 degrees. So that is how we find bearings of A, B, and C from O. But what about the next 3 bearings? The next 3 bearings may not be that straightforward. Why? Because this time, I want to find the bearing of O from A. So if you take note carefully, how do we go about solving this question is to look for clues. If the question says from A over here, it means that you've got to move the crosshair of that compass symbol to position A in this case. So we actually draw our crosshair symbol over here at position A, and to find out what is the angle that it makes with it. Okay, so likewise, we always from the North Pole, go clockwise and stops at position O, okay, where it reaches O. So that is actually the angle that we are finding, which is the bearing of O from A. And if you look at it carefully, it's simply just 180 plus 60. Why? Because this extra portion over here, this is 60 degrees. And how do we get 60 degrees? Because this angle is actually 30. So we can see that there's an alternate angle over here, which is 30. And we take 90 minus away 30. This portion over here is actually equals to 60. So we just need to take 180 plus 60. That will give me 240 degrees. So that is the bearing of O from A. If we look at the bearing of O from B, what we do is we have to move our crosshair to the position B, and then we look for the North Pole and we go clockwise until we touch O. Alright, so in this case, it's a long big loop over here, and it's just simply 360 degrees minus away 20, which is this small portion that's sandwiched over there. Okay, so angle center point is 360, and minus away 20, I end up with 340 degrees. And that is how we find the bearing of O from B. Using the same concept, I need to find the bearing of O from C. So what I need to do is to move the crosshair to position C, and then we start from the North Pole clockwise to where the line is, and then what we need to do is just to calculate what is the bearing. So it's just simply 90 degrees plus minus 45 degrees. That will work out to be 135 degrees for the bearing of O from C. So now that we have seen some basic examples about bearings and understanding if your term is from A, from B, from C, it means that your crosshair got to be at those respective positions. Alright, so over here we have work example number 4. Okay, work example for number 4 tells you about 4 points on level ground of a farm. So in the diagram, we have W, X, Y, and Z. There are 4 points on the farm. You are provided with the distance. WY is actually 10 km. WZ is 22 km. YZ is 15 km. Angle WXY is actually 28 degrees. And then angle WYX works out to be 33 degrees. And another piece of information is Y is due east of X. Okay, so Y is due east of X means that XY is actually a horizontal line. Few things that you need to find is, number 1, you need to find the distance XY. Number 2, you need to find the angle WYZ. And number 3, you need to find the bearing of Z from Y. And part B says that the farmer walks due east from X. You need to calculate the shortest distance possible of the farmer from W. Okay, so in part 1, we are required to calculate XY. If we are required to calculate the angle XY, you look at it carefully, we can make use of the sine rule to do the job. But before we can apply the sine rule, we've got to find angle XWY. And that is quite simple because you know the angles in a triangle adds up to 180 degrees. We just need to find the unknown angle, which is over here and works out to be 119 degrees. Then once we know what is that unknown angle, we can make use of sine rule on the triangle WXY, and that will help us calculate the distance XY. So over here, after applying the sine rule, which just a quick fact is A over sine A equals to B over sine B equals to C over sine C, we have the edge of XY divided by sine angle of XWY. And this is equals to your HY WY, divided by sine angle WXY. So if you put in the values over here, which are based on known numbers that is provided in the question, you end up with an unknown XY divided by sine 119 equals to 10 over sine 28 degrees. And that works out to be XY equals to 18.6299, which is 18.6 kilometer rounded off the 363, because the question did not specify the accuracy required. Alright, so that is actually enabling us to find the distance XY. Next thing, A part 2, you need to calculate the angle WYZ. So in this case, since we need to find the angle WYZ, and all the three edges of the triangle is provided for us, the more logical way of calculating angle is to make use of the cosine rule to help us do the job. So if we use the cosine rule, as what is provided in this equation over here, you can simply work out the value of cos angle WYZ, which is equals to negative 0.53. When you work it out, it is actually an obtuse angle of 122 degrees. Okay, so that is the angle for WYZ. Then part 3 of this question says, you need to calculate the bearing of Z from Y. So remember, if we talk about something that is written in this way from Y, we got to move or draw our crosshair of the compass at the position Y. So in this case, we need to find the angle that starts from north, rotate clockwise to Y. This is the angle that I'll get. Okay, so with this angle, what we do is, we just need to write down bearing of Z from Y as being equal to 122.006 plus 33 minus away 90. Okay, bear in mind that in this case, I do not use the rounded off value, but rather the value that contains 4 significant figures or more. So in this case, it's 122.006 degrees. You need to add your 33 degrees, which is right here. So once you added the whole thing, you just need to minus away the 90 degrees in order for you to find the bearing of Z from Y. Alright, and then when you work it out, you'll notice that it's actually an acute angle, which is 065.005 degrees. What you need to do is to round it off to 1 dp, which is 065.0 degrees. Take note that being a bearing, it must be a 3-digit number, so it's actually 065 in this case. Okay, so the next thing that we need to do is to move on to part B. Part B says we have a farmer that walks due east from X. Okay, so which means this farmer is at position X, he is walking due east in this direction. Because it's actually a horizontal line, he's walking along this straight line towards Y. And then we need to calculate what is the shortest distance that the farmer is from point W. So the whole hint over here is to try to form a perpendicular line, which is now drawn in red over here. So the task is for you to find the height of this red line, which is the shortest distance possible. So if you ever encountered questions that say shortest distance, you've always got to make sure that it is perpendicular to the line that you're referring to. So how do we solve for this unknown line that we have just drawn in? Remember, we actually use our trigonometric ratios for acute angle because we're dealing with a right-angled triangle. So in this case, if you look carefully at the things that we have, we can actually make use of the triangle right here. Okay, with the blue y, we have this distance which is unknown, but we can easily find this vertical distance which is needed in this question by making use of our SOHM. Because sine of the angle, which is given in this case, is 33 degrees. Sine of the angle is equal opposite divided by the hypotenuse, which in this case, the hypotenuse is 10 kilometers. So you work it out, the shortest distance is actually 10 sine 33 degrees. It works out to be 5.45 kilometers, which is in 3 significant figures. Okay, let's move on to the next work example. The next work example talks about a sailing boat. This sailing boat planned to sail from port A to port B, which is 225 kilometers due north of A. So when we mention about something being due north of A, it means that it's vertically above A. Then due to a storm, it sailed at the bearing of 038 degrees from A to B via C. In other words, if this sailing boat is going to pass through C, and you're told that C is 178 kilometers from position B. How much further did the sailing boat have to sail? If C is 178 kilometers B, you'll notice that we will actually have two possible answers for this question. And why do I say there are two possible answers for this question? Because I can have a situation where the sailing boat is traveling from port A to position C1 over here. C1 still makes a distance of 178 kilometers with B and with a bearing of 038 degrees from A. Or I can also have a situation where the boat travels from A to C2, still with a bearing of 038 degrees, and then from C2 the boat travels to port B. So there are two possibilities for this question, or two answers for this question. So, and you'll notice that since we have a fixed distance of 178 kilometers, what we're actually encountering in this case is actually an isosceles triangle, which is named BC1C2. That particular triangle is isosceles in nature, and then since we need to find the distance, we can actually make use of cosine rule this time. Okay, so cosine rule, what we have is, we have the angle of 38 degrees as the bearing, right here. And then what we do is we apply the cosine rule. We can easily work out what is the value of AC. Okay? So, if you notice carefully after applying the cosine rule into the relevant formula, we actually simplify the whole equation, and what kind of equation do we end up with? We actually end up with a quadratic equation. So in this case, having a quadratic equation with some decimal places in some of the digits, what we do is instead of using factorization, which is going to be very tedious, we can make use of the formula. which is minus b plus minus square root b squared minus 4ac divided by 2a. It's one possibility of finding your value of AC. Okay, in this case, it's actually 65.51 kilometer or 289.08 kilometer. Besides using the formula b squared minus 4ac square root of b squared minus 4ac over 2a, what you can do is, a lot of you has the newer calculators. They already have a function in there that enables you to find the roots given the values of a, b, and c, which means the coefficients of AC squared, the coefficients of AC, and the constant. So as long as you input these values, you should be able to get the answer for your distance AC. So two possible locations, two possible answers. But the question did not just stop there. The question actually asks you for how much further did the sailing boat have to sail. So of course we got to find out what is the distance that we have for AC and to find the total distance that we have. And the total distance in this case is from A to C1 and C1 to B. So total distance ACB is given as 65.51, which was calculated for AC for point C1, plus 178 kilometer that you have from position C to position B. So in this case, our total distance is 643.51, and then we have to make use of this answer to minus away the 225. If there was no storm, it means that the ship is able to move vertically upwards, but because of the storm, the ship got to be diverted towards the top right hand corner. Okay, and how much more distance do we need to travel? In this case, for point C1, we got to travel a further 17.5 kilometers. Then we talk about position C2. Okay, at position C2, we need to find the distance of AC to B. Basically, what you do is you work it out, your distance from A to C2, and from there you got to add on to your 178. And when you add up, it ends up with 467.0 km, and then you just need to minus away the original distance that you would have traveled had it not had a storm. So it's actually 467.08 minus 225 to give you 242.08 km, works out to be 242 km, corrected to three significant figures. So after looking at a couple of examples that talks about bearings, as well as your angle of elevation and depression, let's do a quick recap of what we have in this particular topic on angle of elevation and depression. So let's bear in mind, angle of elevation is the angle between the horizontal line and the line of sight to an object that is above the horizontal line. Then if we talk about angle of depression, it will be below the horizontal line. That's how you remember angle of elevation and angle of depression. Okay, if we talk about bearings, a bearing is an angle that tells the direction of one place relative to another. Okay, then we have a few things to bear in mind. Bearings always be measured in a clockwise direction. It must be measured from the north. And it's always written as a 3-digit number. So good example that we actually had is bearing of L from O is 2.1 degrees. Where the angle is 241 from the north, going clockwise to position L. That is how you find the bearing of L from O. So another thing to take note of, if the question says from O, it means that the crosshair of this compass got to be drawn at position O. So if the question says the bearing of D from A, you got to draw the bearing at or the crosshair at position A, etc. Okay, so with that we have come to the end of the presentation, where we talk about the angles of elevation, we talk about angles of depression, we talk about bearings, how it's being done, and of course we talk about all these things with respect to the basic trigo that we have mastered in either the lower set years or the other chapters that comes before this particular section on angle of depression and angle of elevation. So those basic formulas is something that you need to know in order for you to proceed on with your trivial questions.